With you.
You got a better shirt?
No. Would you like to take it home and fix it?
No.
Please don't call me. I don't know what I'm doing.
I'll bring you a new one though. I took someone was throwing away their sharpener in their class. Works like a charm.
Looks like a charm. Hi Chris, thanks for taking your time.
Well, 10:30.
Hey, anybody got gum?
Harry, come on, let's go.
Sorry.
Usually it's
Oh my.
I don't typically see you. I give people I like. Sadly.
So Chris?
No.
Alright, so let's start with 39.
Because I feel like if I get it out, I have to.
The directions for 37 through 43 were for you to write the inverse function. 39 says 0.4 to the x. And they put it in parentheses, but you don't have to have parentheses, not really necessary. But we're supposed to write the inverse function. So just a reminder, the two equations that we've been working with, or the conversions going from one to the other, y equals b to the x was the exponential equation that we learned in the first three sections of the chapter. And the log form, log base b of y is equal to x. So if we have y equals 0.4 to the x, and you're asked to find an inverse, what's the first step of finding an inverse? So we're going to switch the variables, switch the x and the y.
I got that. That's so.
So if you switch x and y, you have x equals 0.4 to the y. So the next step would be to get the inverse by converting it from whatever form that it currently is in into the other form, because that's what the inverse is. So if you have an exponent, the inverse of an exponent is a log. If you have a log, the inverse of the log is the exponent. But that's the only way that you can find the inverse. You've got to convert it to the other form. So looking at what we currently have, like this is really y equals b to the x. That's the form that we have right now. So that means it needs to go into log form. And if I want to write it into log form, I would have log. What's the base of the log? 0.4 of y, well my y is x, and then it's supposed to equal x, which is where the exponent is, so that would equal y. So the inverse, writing it in inverse notation, would be log 0.4 of x. And if you look at the original equation started out with 0.4 at the base. This equation also has 0.4 in the base. The base is just with the log instead of the base being with the exponent. That's how they work as inverses. So the base here is an exponent, now the base is in log form. So that kind of is like that exponential part, that's how they work together. The other one, kind of similar to this, number 41, used e to the x plus 2. So y equals e to the x plus 2. Yeah, that's exactly what it says. So if we want to start finding the inverse, the first step is to switch x and y. So x equals e to the y plus 2. So if you have an exponent and you need to change it as its inverse, it has to go to log form. So currently, here's my y equals b to the x. So all of this represents x. How would you convert it into the other form if it has a base of e? So what goes along with the base of e? Jacob?
what's it called?
It's called the natural log, or ln. So whenever you have an e in the problem, and you're converting it, it needs to have the natural log in its conversion. So instead of using log, we're using ln. So instead of log, this is now ln. My base, here's the base. You can put the base, you don't have to. Anytime you use ln, it's assumed or implied that that e is there. And then I need to take So we have y equals b to the x, here's y equals b to the x. So log base b, well now I have my natural log with an e, and then it's supposed to be of x is equal to the exponent, y plus 2. So when you're changing it from exponential form and putting it in log form, the exponent always goes on the other side of the equal sign. So that exponent like kind of carries down and goes on the other side. So it never goes on the same side as the log, it always goes on the opposite side of the log. Chris and Morgan, please stop. So the last step here, Alex, to get y by itself, what do you have to do? Subtract 2. Again, you don't need this e, so you could just write the ln of x. If you want to have the e, that's fine. The base is implied that it's there. Minus 2 is equal to y. So inverse equals the natural log of x. That's in there because it started out with an e in the original equation. And then the minus 2. So when you have an exponent and you're finding its inverse, the inverse is either going to be a log or it's going to be a natural log, depending what the exponent is that you started with. So if you started with an e, your answer should be natural log. If you started with a number, your answer should have the log with that value. Questions? So then if you go to the last 4 problems, we will do a graph together. We still have a graph in your notes that we're going to go over in a couple of minutes. But the last 4 problems asked you to evaluate the logarithm. And it was set up log base 27 of 9. And that's all it said. And then it said for a hint, it gave you a little hint. It said for each log base b of x, which is how they're all written, it says that you can rewrite b and x as powers of the same number. Well, what the heck does that mean? Amanda?
Maybe the 27 is like 3 3rd, and then 9 is 3.
Right, so 27 is the same thing as 3 cubed. 9 is the same thing as 3 squared. So if you're taking the b, bless you, and the x, that's these 2 numbers here, and writing them as powers of the same number, bless you, that means this number, bless you. So if they're powers of the same number, it has to be written as a power, which means an exponent. And the same number, the base is the part that has to be the same. So you can write it as log instead of 27, 3 cubed, and then instead of 9, 3 squared.
I'm sorry.
She's sick, probably.
So our goal is to try and simplify this. Amanda, did you do anything else with the problem then? Because our goal is to evaluate it. That's what it says, evaluate.
I didn't really know what's like the other ones, like they're like the exponent on top is bigger, so how it's I don't really know.
Okay.
So that was, do we say equal to x?
We can set it equal to x. So we can set it equal to x. And then you can rewrite the problem. So a lot of this is like working with it and trying to rewrite it. So if we rewrite it, we take the base and attach it to the x. Well, my base is 3 cubed. I'm attaching that with the power of x. It's equal to 3 squared. So your base always goes along with this as an exponent. What happens when you take x and 3? What does that become? 3x equals 3 squared. So if you look at your exponents and you solve that little equation for those exponents, what is x equal to? 2/3. Okay, so if you go back to this problem over here, where is the 2/3 at?
So I guess 3 times 3 would equal 9, and then that third 3 would be
Oh.
the 27. Is that what you get?
That's always-
Yes.
That's all.
Hey, dog.
Yes.
What'd you say?
The 3 times 3 equals 9, and that's
Is
the
that
2,
always
and then another
Yes.
3 for the cube, for the square of it. For the cube root of 3.
Adele.
So can you
827.
somehow I got the right
Yes.
answer, but I didn't complete it.
Okay. So when you switch them to the same base, so we have 3 cubed, 3 squared. So when we switch it to the same base, the exponents, that 2/3, is what it simplifies to become. This is the algebra behind it. So this would be the reason why it's simplifying to that 2/3. But if you go back up to your problem, so we have 27 to x, if I put this equal to x, is equal to 9. Well, if we take 27 to the 2/3 power, what does it mean if you have the 2/3 power? How would you rewrite that?
Square root of the cube root of that.
Right? Cube root of this number squared. What is the cube root of 27? 3. What is 3? Yeah. Like, it does work. It makes sense. It's just kind of weird because you're dealing with a log. So, Adele, I'm not ignoring you. I'll be right back. I promise.
Yeah.
So if you look at 55, 55 was dealing with 8 and 32. So log base 8, 32. See if you can simplify this, because I'm pretty sure most of you probably don't have
Hey
it.
Siri. Alright.
I'm really not sure what
All I know.
I think I reversed it.
Yes, you rewrote it.
Guess what? Guess what? Guess what? I can keep going.
For you?
No. Two doggies there. But if you don't finish two spots,
Yeah, you put it in.
but I didn't use the calculator.
No, I was trying to pop my fingers down.
So like, I don't
Okay, so.
Okay, well, so like, you have this written. How did you rewrite it?
well, I wrote it 32 equals 8x.
Okay. So 8 is really 2 what? 2 to the 3rd. 32 is really 2 to the 5th.
So then I just put it over top of each other.
Yeah.
Is it 3/5?
Yeah, so your answer should be not 3/5, 5/3.
5/3, yeah, sorry, 5/3.
So is that work?
Mhm.
That's crazy.
Yeah.
I
Um,
don't really know like, how to do the other ways.
so if you look at 57, so 57 says log base 4 of 128. So if we would write this as 4 to the x equals 128, or vice versa, it doesn't matter whichever way you have it. So 4 is what? 2 squared, and it is 128, right? Yeah. 128 is 2 to the 7th. So if you have your common power sheet, I would suggest that maybe you still want to keep it or like look at it every once in a while, because a lot of these problems are still working back with those powers. So then x is 7 halves, because if I solve for x here, if I set that up, I could say 2x equals 7, so x is 7 halves. But the whole goal is like you converting it to an exponent, so that you have those bases the same. So if the base is the same, that means the exponents can work for each other as well. Questions?
Where?
Alright, so in your notes packet, if you could turn to page 17.
Who's Cassie?
Do you mean to say passing down?
Right now.
I just don't understand.
Okay.
I just don't
You check my homework?
I will. Keep your homework out. Just put it on the side of your desk. I'll get it then.
What page are we on?
Page 17.
Yeah, I look at those. And I don't know.
It's just great.
Okay, so on page 17, at the bottom of page 17 is a final graphing problem that has a translation to it. So it's translating because it says x minus 1 and then plus 2. Our goal is to graph this. But for right now, I don't want you to think about the plus 1 or the minus 1 and the plus 2. So pretend it's not there. You don't have to cross it out, but just pretend that it's not there. So this just says y equals log base 3 of x. That's really what we're going to focus on right now. What would be the exponent equation that we could use to help us graph this, Dave?
Y equals 3 to M.
Right, y equals 3 to the x. So that's what we're going to use in our t-chart with -2, -1, 0, 1, 2. Because you should be able to quickly plug numbers in there at this point and fill out the y values. So Jacob, the y values would be?
I'm confused. Okay.
What are they?
1 9,
Oh, sorry, 1, 9.
1/3, 1 3.
So these would be the values that we would use if we were graphing the exponential equation. We can use them also to help us graph the log equation by taking those values and doing what with them? Flipping them. So to graph a log, you need the exponent in order to graph the log. So taking the same numbers, just switching. So 1/9, 1/3, 0, 1, 9, and then -2, -1. Sorry. Ugh.
I
1, 3, 9. Dave?
So even when I thought this was only when you were doing inverses.
Yeah, that's what
I mean, if you switch x and y to find an inverse, in order to graph, you also have to switch x and y to graph it. So if you're switching x and y to write the inverse equation, in order to graph it, we're going to do exactly the same thing. So if this is my exponent, the inverse, in order to get it, is to switch x and y.
Every time we're graphing on the line.
Every time you're graphing a log, you're using the exponents, flipping them to graph the log.
Interesting.
And then
So wait, on the
Yeah.
homework, we had problems similar to this one, and I got like y equals 2, like x minus 3, whatever, as your problem to do, and then so I plugged those in and did that math. So I would have to flip it again to get the log.
Yes. So we have y equals 3 to the x. We're not using the -2. Never use the -2, the +2, whatever. You should just have an easy exponential equation to solve for so that you can plug them in quickly. That's the whole goal. Like whatever your exponential equation is, you should be able to quickly plug those values in. And then flip them. So now we have the log. So these points here represent our log graph. So at 1/9, and I changed mine to just count by ones. At 1/9, you're going down to -2. At 1/3, we have -1, and then 1, 0, 3, 1, and the last one will be off the graph, which is okay, it's fine, no big deal. So when you graph it, it should be vertical along the y-axis, and then it starts to curve to connect to your points. Vertical next to the y-axis, sorry. So it should be vertical with the y-axis, it curves up, and it starts connecting with your points. I counted mine by ones.
Oh, why did they?
So then, to translate it, so this is the first graph, I don't ever want you to put the -2, the +2, the -3, the -4 into the equation. So you should be thinking of the ordered pairs in the basic equation. Because then my second graph should just be a translation by hand of what you currently have. So how does this graph move? How does it shift? Jacob?
Right one up.
Yeah, so this part moves it right 1, and the +2 says it should go up 2. So by hand, taking your points, sliding them right and up. So my first point goes right 1 and up 2. And then we're moving right 1 and up 2.
Does it matter, like, not saying I do this, but does it matter if you translate, like,
No.
before you do
It-
inverse? Or yes?
Yes. Yeah. Doesn't matter if you go up and then right. So my second graph is in blue. 8.
So now is that second number in the equation, that the 2?
Mhm.
So that's not the range.
That
That's
is
not.
not-
The 70.
Exactly.
So that's gonna flip too, like to the denominator.
Yes. Yes. So if you look at your graph, look at the range. How has it moved left and right? Because that's what the graph is doing. It's shifting left and right. So how does that change your domain? So what should the domain be?
1, 2, 3.
1 to infinity.
Oh, crap.
So the graph has moved now, and it's just after x equals 1. The range, Aaron, is
Negative infinity positive.
negative infinity to positive infinity. So this time the domain is changing because it's moving to the right. So because of that x minus 1, that's your h value, that changes the domain. So that's what's shifting the domain to the right. So when you're graphing these, you should always have 2 graphs if there's a translation. The first value that you're finding is just whatever the base is. So the base was 3, that's creating my equation, y equals 3 to the x. If the base was 5, I'd have y equals 5 to the x. If it was 10, I'd have y equals 10 to the x. But that minus 1 plus 2 should not affect any numbers that you're plugging in here. It should be really quick, easy. These numbers here on this side, they should be pretty quick for you to come up with. Because you don't have to worry about subtracting a 1 and adding 2. That makes those fractions ugly. They shouldn't be horrible fractions to work with if you're ignoring those extra pieces of information. Questions? So I have a worksheet, and it actually doesn't have any graphs on it. I kind of wish I should have put graphs, but there aren't any graphs.
Worksheet?
It is a homework worksheet.
Might be that.
On Monday, yeah, just give me a minute. Can you give me a minute?
Yeah.
On Monday, we are starting section 7.5. I had planned to start it today, but I feel like you needed an extra day to kind of just go over things because the conversion part, going from a log to exponent, you have to be solid on in order to do anything else, like in the rest of the chapter. So quickly, you should be able to translate an equation from a log to an exponent, from an exponent to a log.
Yeah.
Like that needs to be a quick translation. So this worksheet has 42 problems on it. They're not that long and involved. It's like one-step problems. By the end of it, you should be able to convert a log into an exponent within like a second. Like by the time you get through them, it should be really quick. They should not take you long. You might start off thinking a little harder, and then you'll kind of work through it, and it should be easier.
Just like
On Monday, you will have a small quiz. That small quiz will be like this worksheet. There'll be a few problems that you'll have to convert, and then some of them you'll have to solve for x, like the worksheet asks you to do. So again, there's no graphing on here. You will have to use inverses for the last handful of problems. So the last part of the worksheet is using the inverses. I am going to give you back your quizzes that you took on Tuesday.
I couldn't be wearing the Friday night. Yeah.
So please use this time. You could come out of here with this whole front page done if you're using the time wisely. You must show a little bit of work when it asks you to, and don't use a calculator unless it says to. There's only one section that says to use a calculator. So the rest of it should be calculator free.
What? Someone come out and do number 1. Jacob.
Maybe you want to write the 2 conversions at the top of your page. So y equals b to the x, log base b, y equals x.
all the graphs now.
Okay, okay.
And then the other stuff, I don't know what I'm doing, so I somehow found the right answers, I'm just not sure.
Thank you.
Solid.
You get three? Is that all what you're doing?
Yes.
That's it for